The sign of that enthalpy will depend on the endothermic or exothermic. Endothermic means energy will be absorbed, exothermic means energy will be given out from the crystal. Hydration means it related to water, and the formation of specific hydrate when 1 mole of an anhydrous or partially hydrated salt combines with specified moles of water. Whatever the reversible or irreversible reaction, if it is getting to converted, the sign will be changed automatically. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we are starting up session 6 from the chapter Thermodynamics. In the last class, we have discussed about principle of equipartition of energy, that is degrees of freedom, and overall that concept was an extra information, and this is thermochemistry also we have discussed in last session. This is in your syllabus. So you have to understand what is thermochemistry. Now in this session we will discuss about lattice enthalpy and Born-Haber's cycle, which is important concept for your examination. So lattice enthalpy and Born-Haber cycle today we will discuss with some of the numericals. First we will see what is lattice enthalpy. Enthalpy means energy, lattice means crystal. So the lattice enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of ionic compound dissociates into its ions in gaseous states. 1 mole of ionic compound should get dissociates to its ions in gaseous state. Compound into ions it getting to convert. See here compound, it is ion formation in gaseous state. For this ionic compound NaCl it needs 788 kilojoule per mole, that lattice energy. Since it is impossible to determine lattice enthalpies directly by experiment, we use an indirect method where we construct an enthalpy diagram called Born-Haber cycle. Means directly we cannot determine how much enthalpy has been produced or how much enthalpy has been used here. So the indirect method is Born-Haber cycle, that is a enthalpy diagram. So we will use here mainly to identify the lattice enthalpy. Born-Haber cycle will be used. See, this is Born-Haber's cycle. This cycle relates lattice energy represented by U of a crystal to other thermochemical parameters like heat of sublimation, for heat of formation, heat of dissociation, heat of its ionization energy, electron affinity, and etc. These are thermochemical parameters which can use or which can observe in Born-Haber's cycle. This is the overall Born-Haber cycle. Ionic compound in the formation of ions in gaseous state. Through ions it will form again ionic crystal. This will be called as heat of formation. Means from the ions it is going to form in a crystallized nature. First solid, that Na, will be get sublimized, that is heat of sublimation means it converted into gaseous state. By using ionization energy or ionization enthalpy, it will form into ions stage. First solid to gaseous, in the gaseous state it will form its ions, that is also in gaseous state. This is chlorine in the gaseous state. In the heat of dissociation it will also form or it will also convert into gaseous state. Next electron gain enthalpy is there. It will loses its electrons, it will gain its electrons, right? So it will form anion, it will form cation. From anion and cation only it will form an ionic compound, we know that. So here lattice, by using lattice enthalpy, these two cation and anion will form a crystal. Okay, how these parameters will be moved, once again I am telling. This is solid Na going to convert into gaseous Na. From that, using ionization enthalpy, it will form cation. Similarly, chlorine in gaseous state, it will also dissociated in chlorine gaseous state. By using electron gain enthalpy, it will form chlorine anion. By using cation and anion, the crystal will form by using lattice enthalpy. This is about Born-Haber's cycle. Lattice energy of a crystal is the energy evolved when 1 mole of the crystalline solid is formed its constituent ions in their free gaseous state. Means it will be evolved from the compound to convert the solid compound into gaseous state into its ions. Formation of NaCl crystal involves several steps. that is heat of formation of NaCl will be algebraic. Sum of all the energies termed involved in these steps. See here, by Hess law, it is also an important law, heat of formation will be the sum of heat of sublimation, ionization energy or enthalpy, heat of dissociation, that is heat of gain enthalpy, electron gain enthalpy, and this is lattice enthalpy. The sum of all the types of thermodynamic parameters. Actual sign of enthalpy terms depends on the endothermic and exothermic nature in each step. Wherever the enthalpy have been seen, the sign of that enthalpy will depend on the endothermic or exothermic. Endothermic means energy will be absorbed, exothermic means energy will be given out from the crystal. Lattice enthalpy and electron gain enthalpy are generally negative. It will be generally in Born-Haber cycle, it will be negative only. Born-Haber cycles are generally used to calculate the lattice energies which are difficult to measure experimentally. Application of Born-Haber cycle is, in experimentally it is difficult to calculate the lattice energy. So indirectly we can calculate by using Born-Haber cycle. So that is the application of that cycle. Next, enthalpy of solution. Enthalpy of solution of a substance is the enthalpy change when 1 mole of it dissolves in a specific amount of solvent. The amount of energy which will be substance or 1 mole of solute is dissolved in specified amount of solvent. The enthalpy of solution at infinite dilution is the enthalpy change observed on dissolving the substance in an infinite amount of solvent when the interactions between the ions. If it is solute also infinite and solvent will also infinite, the changes can be calculated are negligible. This enthalpy of solution in water is determined by the selective values of the lattice enthalpy, enthalpy of hydration of ions as solution, lattice enthalpy of solution, this is lattice enthalpy and this is enthalpy of hydration. In water you have to find out by this formula, hydration energy. Next, enthalpy of dilution. It is known as that enthalpy of solution is the enthalpy change associated with the addition of specified amount of solute to the specified amount of solvent. We have to know what amount solvent is present and what amount of solvent is also present to dissolve that solute into solvent at constant temperature and pressure. Next, enthalpy of neutralization of an acid by base. We know that acid and base getting neutralized means salt and water will be liberated. It is the enthalpy change accompanying the neutralization of 1 gram of equivalent mass of acid by 1 gram of equivalent mass of base in a dilute solution. This is aqueous HCl, this is aqueous NaOH, this is acid and this is base. It will form salt and water at this enthalpy. Next one, the enthalpy of neutralization of a strong acid by strong base is always a constant. The enthalpy of neutralization means at a strong base and at a strong acid it is always a constant. A strong acid and strong base ionize completely in a dilute solution and the neutralization will simply involve the formation of 1 mole of water from 1 mole of aqueous H plus and 1 mole of aqueous OH minus. Means in the dilute solution it will give 1 mole and 1 mole equivalent, but it is a strong base and strong acid means it will give the constant values. In case of weak acid and a strong base or a weak base and a strong acid, neutralization, some amount of heat is used to ionize weak base or weak acid. Because the contradictory parts will be there, if it is weak base with strong acid or weak acid with strong base means some amount of energy will be used to ionize that ions. Hence, the energy released during the neutralization involving a weak acid or a weak base will generally be lower than that of the strong acid and strong base for neutralization. There are a few exceptions for this. For example, HCN, NaOH, it will give NaCN with water. It is having this amount of kilojoule per gram equivalent mass. This is weak acid and strong base. For this is an example. This value will be lower than that of the strong acid and strong base, how it will interact. Next, enthalpy of hydration of a crystalline solid. It is the enthalpy change accompanying the formation of a specific hydrate when 1 mole of an anhydrous or partially hydrated salt combines with specific moles of water. Hydration means it related to water, and the formation of specific hydrate when 1 mole of an anhydrous or partially hydrated salt combines with specified moles of water. Means specified moles of that salt will be get dissolved with specified amount of water. For example, copper sulfate with water, it will give copper sulfate pentahydrate. This is the general formula now for whatever we use copper sulfate in our laboratories. Note, heat of hydration of anhydrous salt equal to heat of solution of anhydrous salt minus heat of solution of hydrated salt. Next, enthalpy of ionization of a weak electrolyte. It is the enthalpy change accompanying the complete ionization of 1 mole of an electrolyte in solution. Means it is also an energy that complete ionization of 1 mole of an electrolyte in a solution will takes place. See your water getting to H plus and OH minus at this 56 kilojoule per mole. Heat of precipitation, phase transitions, that is polymerization, hydrogenation are other types of heats of reaction. By using heat only precipitation will be taken place phase transitions like sublimation, vaporization, condensation, polymerization, hydrogenation. These needs heat supplements or else these reactions will not takes place properly. Next problems. Enthalpy of transition of some allotropes are given below. This is sulfur, this is phosphorus, this is carbon. What they are giving? Here the respective values are giving. Choose the most stable allotrope in each of the given pairs. The answer is rhombic sulfur, next red phosphorus, next graphite. Because first is rhombic sulfur, it is having plus 0.297. Next, the red phosphorus having minus 18 kilojoule. Next one is plus 1.9. It is having the most allotrophic, means the graphite is most stable allotrope of carbon. Next one, the enthalpy of neutralization of HCl by NaOH is minus 55.9 kilojoule per mole. If the enthalpy of neutralization of HCN by NaOH is minus 121.1 kilojoule per mole, the enthalpy of dissociation of HCN is, this is HCl plus NaOH gives rise to NaCl plus H2O. This is having minus 55.9 kilojoule per mole. HCN plus NaOH gives rise to NaCN plus H2O gives, that is another enthalpy minus 12.1 kilojoule per mole. Enthalpy of dissociation means delta H2 minus delta H1. You have to subtract this by H2 to H1. What will happen? It will around come 43.8 kilojoule. That is the answer. Next one, laws of thermochemistry. Lavoisier and Laplace law. Consider the reaction, that is water in gaseous state, that is steam is treating with graphite. It will form carbon monoxide and H2 gas. It is having 131.2 kilojoule per mole, or water in carbon graphite gives 131.2 kilojoule to form carbon monoxide and H2 gas. The reverse reaction will be exothermic here. The reverse reaction means CO plus H2 will form carbon in solid and water in minus 131.2 kilojoule. Enthalpy change in a chemical reaction is equal in magnitude but opposite in sign. Enthalpy change when the reaction is reversed. This is Laplace and Lavoisier law. See here, this reaction is getting to reverse but sign is getting to change, because it will form an exothermic reaction from endothermic reaction. This statement was stated by Lavoisier and Laplace law. Whatever the magnitude, whatever the reversible or irreversible reaction, if it is getting to converted, the sign will be changed automatically. Next, Hess law of constant heat summation. Enthalpy is a state function, means it will not dependent on path. Hence, the change in enthalpy is independent of path taken. Consider for example the formation of CO2 in two different paths. First, how the carbon dioxide can be formed? Carbon solid, that 1/2 of oxygen into gaseous, it will form carbon monoxide. It is formation first one. That carbon monoxide will treated with again oxygen. it will form carbon dioxide. This is path 1. This is carbon with 2 molecules of oxygen, it will also form carbon dioxide. By 2 ways it can form carbon dioxide, but since enthalpy is a state function, it doesn't want to depend on path. See here, delta H1 and H2 393.5 kilojoule means after adding these two it will form this amount of energy only. The heat change involved in the formation of carbon dioxide from its elements is the same whether the reaction follows path 1 or 2. Whatever the path 1 or 2, the energy or enthalpy of used to form a carbon dioxide is same. This proves that enthalpy is a state function, not a path function. Enthalpy changes accompanying a reaction is the same whether the reaction takes place in one step or more steps. This is his law. Understand? In path 1, if you add this one and this one, it will come around minus 93.5. If you choose part 2 also, it is already minus 393.5. Means energy will be same in path 1 and path 2. So, it doesn't want to depend on path. It is depending on initial state and final state. That's it. That's stated by Hess law. The enthalpy of formation of ammonia is minus 46.0 kilojoule. The enthalpy of change for following reaction, that is ammonia, is giving out N2 and 3H2. How much? Given that half N2 plus 3 by 2 H2, that is reversible reaction NH3 will form around minus 46 kilojoule. NH3 gives rise to half N2 plus 3H2, that is delta H 46 kilojoule. The heat energy change 2NH3 N2 3H2, that is 46 into 2 92 kilojoule. So overall delta H will form 92 kilojoule. This one is the answer. Next one, the enthalpy of combustion of C6H6, that is benzene, is minus 3250 kilojoule when 0.39 grams of benzene is burned in excess of oxygen in an open vessel. The amount of heat evolved means it is an exothermic. This is the reaction for this amount of enthalpy, that is in kilojoule. 78 gram of benzene on combustion liberates 3250 kilojoule. If 0.39 gram of C6H6 on combustion liberates 0.39 into this amount by 78, then amount of heat evolved is 16.25, that is answer C. Next one, 6226 kilojoule evolved by the combustion of a certain amount of ethylene. If the heat of the combustion of ethylene is 1411 kilojoule per mole, then the volume of O2 used in the reaction is, see this is again the reaction, ethylene means C2H4, it is around minus 1411 kilojoule per mole. Total heat liberated 6226 kilojoule and 1411 kilojoule heat liberated when 2.5 into 22.4 liters of oxygen, that is O2, is used. For that what you have to do, 2.5 into 22.4 into this amount of total heat divided by 1411, that means 247 liter of oxygen is used. So which is the option? B is the option. So in the next class, we will discuss about resonance energy, spontaneous process and non-spontaneous process. I hope you have understood whatever I have taught today. We will meet in the next session. Thank you.